Okay, so I'm going to try and explain section 4.4, graphing a quadratic in vertex form. Okay, so I'm going to graph this equation here, y equals 1/2 x minus 4 squared plus 2. Let's describe these transformations in a moment. Okay, let's look at the graph first. Okay. Whenever you graph a quadratic, and I'm going to graph this by showing all the different transformations that are happening. Now, I gave you an investigation that I asked you to use Desmos to see how everything shifts. So now we're going to do it without the use of Desmos. So you always begin with y equals x squared. So this is where you start, y equals x squared. Okay, and we're going to do this by table of values. So I do my x and then my y. It does not matter which x and y values you choose, but of course I'm going to pick the values that aren't that large, right? So I'm going to pick a couple of negatives, -2, -1, 0, 1, and 2. And then I'm going to sub it into here, y equals x squared. So to find y, I actually need to square these, right? So I know anytime I square a number, it has to be positive. So -2, I square it, it's going to be 4. -1, I square it, it's going to be 1. 0 squared 1, 1 squared 1, 2 squared 4. Now I'm going to plot it here. Okay, so I've already done my grid and I've done my scale. It's if you show all transformations, it's easiest if you go by a space and a scale of 1. And hopefully you'll see why in a moment. So I'm going to just quickly graph this. Alrighty, here we go. Okay, so remember a parabola is a curve, so do not connect these points with a ruler. Put an arrow on each end to show that it's continuous. Make sure you label it. There we go. Okay, so there's the first one. The next graph, I'm going to use different colors. I'm going to use this pencil here. The next graph is going to be with the a value. So the a value is 1/2. Okay, so I'm going to graph y equals 1/2 x squared. Okay, I'm actually going to use these same x values. Okay. And this time, I'm going to square the x's and then times it by 1/2. But I've got the x squareds right here, right? So I know if I take -2 and I square it, I get 4. And I know 1/2 times 4, or half of 4, is 2. Do the same idea. You can use your calculator here, right? Take -1, square it. You get 1. Times it by 1/2, you get 0.5. 0 squared, 0. Times it by 1/2, still 0. 1 squared, 1. Times it by 1/2, 0.5. And then the same idea here, 2 squared, 4. Okay, times it by 2, 2. Plot this. So, okay, I got -2, and this here is at 2. -1 and 0.5. 0 and 0, 1 and 0.5, 2 and 2. This will help when we describe, okay? So what's happening with my quadratic with that 1/2, right? It's actually becoming wider. Okay, we call that a vertical compression. Okay, so think of something and you're compressing it, it's going to become wider. Okay, so now I've graphed with the A. Now I'm going to look at the H and use another color. And we don't need a table here with H. Now, if you look at that summary page that I gave you, H is horizontal. Okay, and a horizontal translation is either left or right. Now, the horizontal translation is always the opposite sign that's in here. So my H value, even though it says x minus 4, my H value is actually +4. Because when I subtract a positive number, so if H is 4, you put 4 into this equation, you're going to get x minus 4. So this is actually going 4 units to the right. So with the graph that I just did, I'm going to take each of these points and go 1, 2, 3, 4 to the right. So there's that one. This one, 1, 2, 3, 4 to the right, 4 right, 1, 2, 3, 4, keep doing it. And then this one, 1, 2, 3, 4. So there's my next graph. Okay, and so this is with H. Okay, oops, new color. The final one is with the K. Now again, if you look at the summary notes, K is a movement going vertically up or down. Because it's positive, you're going up. And how many going up? Whatever this is. So from here, I'm going to go up. The graph that I just left off, I'm going to go up 1, 2. This one, 1, 2. This one, 1, 2. This one, 1, 2. And then the same idea here. And now I am finished. I've done all of the transformations like that. Okay, and you're done. So now let's go back up to A. So when you're asked to describe, identify what your A value is. A is a 1/2. Remember, H is always the opposite sign, because here, if I told you H equals 4, you're going to put in X minus 4. H is positive. And then here, K is positive. So this here is either a stretch or a compression. So looking at your number line for a moment, here's 1, -1, here's 0, here's 1, here's 2, you know, it keeps going. Any of these numbers in between 1 and -1, these are all going to be compressions. They're all going to be wider. Anything bigger than that, these numbers here, these will all be stretches. They'll be more narrow. So because 1/2 is in between here, this is a vertical compression by a factor of 1/2. Okay, because factor means multiplying. We multiplied everything by 1/2. This is a horizontal, H horizontal, translation 4 units to the right. Okay, this is up or down, vertical, translation up 2 units. So now I've described it. I've shown you all the transformations. Now let's look at the properties. Okay? Are you all right? My daughter's holding her up the camera, so see if she needs a break. You okay? Yeah. Okay. So now the direction of opening is, how does this parabola open? Well, here it opens up. So you tell me it opens upward. How do you know it opens upward? If A is a positive number, it's going to open up. If A is a negative number, it's going to open down. So you can read all of these properties just from the equation. The vertex, it's right here. What's the vertex here? X is 4, Y is 2. 4 and 2. Well, where do you see that? It's right here. It's your H value and your K value. The equation of the axis of symmetry is this here, where it, you know, the line of symmetry. Well, what is that? X is 4. So I write that here, X equals 4. Well, where do you see 4? 4 is H. The stretch or the compression value is your A value. Oops, here it's 1/2. Here it's always the A value. Now, I'm using the word domain. This is a grade 11 term. Your textbook is using values X may take. So you look at the very last graph and you say, hey, is there any number on this very last graph that X can't be? So what I often do is I start here at the vertex and I look at all the numbers to the right of X. And I say, hey, there's somewhere on my graph. Because of this arrow, it's continuous. It continues in this direction. So again, it's somewhere on my graph. Then I look at this side. It's somewhere on my graph. So I know that for a quadratic, the values x may take can be anything. And it will always be anything, okay, in grade 10. So let's go back here. So this is any number. Now, the y value is a little different. So I look here, and I start here at the vertex, and I look at the numbers above 2, and I see all these numbers are somewhere on my graph. Now I look at the numbers below 2, like 1, and I'm looking at this final blue graph, and I say, okay, 1 isn't on my blue graph. Neither are any of the numbers less than 2. So I know every number less than 2 is not on my graph. So what is? Anything that's 2 or greater. So I write that as y is greater than or equal to 2. Well, where do you see 2? It's k. So if it opens upward, it's going to be y is greater than or equal to k. Now, if it opens downward, it will be the opposite to that. Okay? The max or the min value is always your y value. Is this value for y? Is it the greatest y value, maximum, or is it the lowest y value, minimum? It's the minimum, right? So I'm going to say minimum value y equals 2. And again, every time it opens upward, it's a minimum, y equals 2. If it opened downward, it's a maximum. Not equals 2, equals k. Y equals k. And there you have it. Now, okay, now let's try the next one. So again, I'm going to do the description first. Describe the transformations as they relate to y equals x squared to y equals negative 3x plus 2 squared minus 1. So this is the most basic quadratic or parabola. Often it's called a parent function. So again, I'm just going to rewrite the standard form. Okay, so when I describe the transformations, I look at what each of the values are, right? So I know a here is negative 3. Now I look at h. Remember, this is x minus h. Here it's x plus 2. Well, how does a minus sign change to a plus sign? I know that I had to have subtracted a negative. That is what makes the sign change, right? So I know my h value here is negative 2, okay? Because in order for x minus h, that subtraction to change to an addition, you know you had to subtract a negative. That's what changes the sign, okay? So it's always the opposite sign, okay? And k then is negative 1. Now, A is important. It gives you the shape of the graph and it tells you the direction of the opening. Because of this minus sign, I know this is going to open downward. If A is positive, it opens up. If A is negative, it opens down. So this tells me I have a reflection. And the reflection is always in the x-axis. Okay? And the other example was a vertical compression, right? Remember I did this number line? Okay, so I'm going to kind of do it again here. If it were numbers in between 1 and negative 1, that's what we had in the earlier example, that is a vertical compression, which means it gets wider. Now the numbers that I'm looking at here, this negative 3, well, negative 3 is somewhere here. It's these numbers here, right? Which is what I have. This is a vertical stretch, which is what I've got. A vertical stretch means that it becomes more narrow. So here, I'm going to say I have a vertical stretch by a factor of 3. I don't write the negative because I've already talked about the negative right here, okay? So then I'm done with A. So I know this is going to open downward, and I know it's going to become wider or stretched. H, you can remember H is horizontal. Horizontal left or right. If it's positive, right. Negative, left. So I know this is a horizontal translation. Two units to the left, or left 2 units. This last one is, sorry, I got my ruler here, is vertical. It's up or down. Because it's negative, I know it goes down. If it was positive, it would go up. So this is vertical. Translation. 1 unit down. Okay, so now let's do the graphs. So now we're going to start off again with the parent function. So I did that already, right? So just this, I use the exact same values I had before, -2, -1, 0, 1, and 2, because I don't want my numbers too big. And then I've already plotted, when I take -2, I squared, I get 4. I get -1 squared, I get 1. 0 squared, 0. 1 squared, 1. 2 squared, 4. And then I graphed it. Okay? Now when you do the transformations, go from left to right, whatever you see first. So I start off with the parent function, or y equals x squared. Now I'm going to do this one here. I'm going to do the a, the -3. So I'm going to do that here. Okay, so I'm going to do that with just a different color here, my pencil, -3x squared. Okay, I'm going to use the exact same x values, -2, -1, 0, 1, and 2. Right, now I've already squared all of these, right? So if I take -2, I square it, I get 4. But now I got to times it by -3 to get -12. -1, I square it, I get 1. Times it by -3, I get -3. 0, I square it, 0. Times it by -3, 0. 1, I square it, is 1 times -3, -3. 2, square it, 4 times it by -3, -12. Now I'm going to plot this. Now it should, if I describe this correctly, it should open downward, and it should be more narrow than this one. Okay, so I go -2, -12. Okay, -1, -3. 0, 0, like that. Okay, now it's a good idea to do your scale. Then of course you connect it, put arrows. Now it's a good idea to do your scale, you know, what to go by after you do this table. Okay, so do these tables first. Look at this number. See, I knew I had to get to -12 because if you do this first, then you don't have to start erasing anything. So of course you're going to label it. Now everything else is just moving this. Look, make sure you can see those 5 points well. Okay, so I'm just going to make them a little bit bigger. The next thing I'm going to do is this horizontal, right? I know I'm going 2 units to the left. So from the graph that I just did, I take each of these 5 points and move them left. So 1, 2, there's that one. 1, 2, that one. I'm going to move, so I move this one, 2. Now this one goes over to the left, this 2 to the left, and this one 2 to the left. And there I've got with my H. And then of course you label it. Okay, and then the final one is, here, my other color, this here. I know I'm going down. How many? 1, because it's a 1. So from, I'm just going to make this a little bit easier to look at. Okay, so from again, these 5 points, I'm going to move them each down 1. This goes down 1. This goes down 1. So does this. So does this. This is now at 13. Right, so this here is -13. And then there is my final graph. Y equals -3x plus 2 squared minus 1. And the properties that we're going to go over is the final graph, the blue one. Okay, so let's look at these properties again. Direction of opening. So we go to the blue graph. What direction is it opening? It opens down. Again, I know that because my A value is, move it up to the A value.
Sorry.
That's okay. Is negative. Okay, let's go down to the vertex. Vertex here is at -2 and -1. Remember, that's your H value and your K value. So here, -2, -1. Okay, axis of symmetry always goes through the vertex. It's the X value. So here, X equals -2. Stretch or compression factor, we talked about this. It's 3. That's my A value. The values X may take, this is the easiest one. Any number, that never will change. Okay, values Y may take. So again, let's look at the last graph, which is the blue one. I look at Y. I always start at the vertex. Vertex is -1. I look above the -1. Are any number above -1 on my blue parabola? And the answer is no. So that anything below -1 is part of my parabola. So all these are somewhere on my graph. So I know the values Y may take is all the values, including -1, and the ones that are less than -1. So I write it like this as an inequality. Y is less than or equal to -1, which is my K value. Now, is that Y value the largest Y value, or is it the smallest Y value? And it's the largest. It's a maximum. So this is a maximum value, and Y equals -1. And there you go. And I hope you get it now.